Gravitation. Gravitation is the force which holds Moon in orbit around Earth. Also, Earth orbit around Sun. Gravitational force also reaches across the intergalactic spaces, holding galaxies together in space. And also, this force is responsible for the most mysterious structure in the universe called black holes. In 1665, 23-year-old Isaac Newton made a basic contribution in physics. He proposed that a force that holds Moon in the orbit around the Earth is the same force that makes an apple fall from a tree. He concluded not only the Earth attracts towards the apple and Moon, but also every body in the universe attracts every other body. Newton proposed a force law, that is Newton's law of gravitation, that every particle attracts another particle with a gravitational force. This gravitational force is directly proportional to the product of the masses and inversely proportional to the square of distance between their centers. The gravitational force is equals to g m1 m2 by r square. m1 and m2 are mass of particles respectively, where r is the separation between their centers. And capital G is universal gravitational constant whose value is fixed at every place of the universe, that is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Newton's law of gravitation strictly apply on particles only, Earth and the Moon and other celestial bodies. You might be wondering what we are talking about right now. Now let's see the case of the apple and the Earth. From the perspective of the apple, Earth is a huge globe. So Newton also explained a shell theorem. A uniform spherical shell of a matter attracts a particle that is outside the shell as if all the shell mass were concentrated at its center. Now we can assume Earth is made up of infinite spherical shells, and now you can relate why we treat them as particles. Gravitation near Earth's surface. Let us assume a particle of mass m located outside the Earth at distance r from the Earth's center. Gravitational force on that particle will be g capital M into small m by r square. If the particle is allowed to fall freely, it will fall towards the center of the Earth under the action of gravity with an acceleration. We shall call that acceleration due to gravity, denoted by a small g. So we can say the acceleration due to gravity is g m by r square. Now we plug in the value of capital G's, capital M and r. We deliberately put the value of r as the radius of Earth because we are talking about the value of g near the Earth's surface. Therefore, we can take an approximation that small r is roughly equals to capital R, that is the Earth radius. But the value of g do vary with the location. Why? We have the following points which will explain it. Earth's mass is not uniformly distributed, that is the density varies with distance. Secondly, Earth is not a perfect sphere. And thirdly, Earth is rotating. Thank you so much for watching. And if you feel like that this lecture was worth watching, then consider subscribe and press that bell icon so that you can get more update about our uploads. Thank you so much.